Hello everyone, in this video we are going to see all about depth first search algorithm and its practical implementation using Python. Breadth first search and depth first search are the two most common graph traversal technique. First, we will visualize how the depth first search algorithm works, and we will also see the practical implementation of the algorithm. Next, we will start coding the algorithm in Python. For traversing a graph, depth first search starts with the root node and explores the graph in depth as far as possible. After reaching a dead end, the algorithm starts backtracking and eventually completes the search. The stack follows first in last out principle, that is, the last element entering the stack will leave the stack first. Let's visualize DFS with an example. Let's assume that A is our root node and we will start traversing the graph from this node. We'll keep going to the maximum depth of the branch and then backtrack from there and search in another branch. We will push the root node A to our stack and then find its child nodes, which is B and C. As per first in last out principle, we will pop the node A and push the neighboring nodes B and C into the stack. Now we will mark the node A as visited. I am color coding the visited node in black color and the nodes that are in stack in blue color, and I am representing the unvisited node in white color. For B, the neighboring nodes are D and E. So we will pop B and push the neighboring nodes D and E into the stack. We will mark B as visited. Now we reached a dead end and we will pop D and we will mark D as visited. E is also a dead end. We will pop E. Now our stack only has C. For C, the neighboring nodes are F and G. We will pop C and push the neighbors F and G into the stack. Now C become our visited node and the nodes F and G are dead ends. Now we will pop F and mark F as visited and we will backtrack. Now G is the last node. We will pop G from the stack and we will mark G as visited. We have traversed all the nodes of the graph and our stack becomes empty. Our graph traversal will be from A to B, B to D, D to E, E to C, C to F and F to G. I hope you got a fair idea of how the graph traversal works in depth first search. Let's implement this using Python. Here is my graph, which is of type dictionary, and I have nodes from A to G. Node A has child B and C. Node B has childs D and E, and node C has childs F and G. Nodes D, E, F and G are dead ends, so these nodes doesn't have any child. So we are having empty list for these nodes. I have defined a function DFS which accepts three parameters: graph, node and visited. In the first argument, I will pass this graph as my argument, and in the second argument, which is node, I will pass the root node. In my case, the root node is A, so I am passing A as an argument to the node. And initially I don't have any nodes visited, so I am passing an empty list in the visited argument. Let's implement our depth first search. The first step is, if the root node A is not visited, we will append the node to the visited list. If node not in visited dot append the node. Next, if the root node has child nodes, we will repeat the same steps and recursively call the depth first search for the child nodes. Let's implement that. For n in graph of node, which is the child nodes, depth first search of graph, comma, n, comma, visited. We are recursively calling the depth first search for the child nodes. At the end, we will return the visited. Return visited. That's pretty much it. Now we are printing the visited here and we are calling this function as an object. Our object is visited. Let's save the program and run. Here is our result. First, we are starting from A and then we are traversing to B, then to D, then we are traversing to E, then we are backtracking and traversing to the next node of A, which is C, then we are traversing the child node of C, which is F and G. I hope you got a fair idea of how the depth first search works, and I'm sure that you have learned something new today. If you do like this video, please consider to subscribe and I will see you in yet another interesting video. Thank you.